Hi students, MCQ number 29. N small drops of same size are charged to V volt each. If they coalesce to form a single large drop, then its potential will be. So the new potential of the larger drop has to be determined. Now we can see a small single drop of a radius small r. It holds a charge small q, and on its surface the potential is V. So like this, n number of small drops are combined together. Then what will be the new potential V dash on its surface? We have to find out. So now you can see that the charge on the larger sphere is capital Q and the charge on the smaller sphere is small q. So capital Q must be equal to n times small q. So this is the first step of understanding. Our understanding? Because each charge is holding a charge small q. Therefore, the larger drop must have a charge capital Q equal to n times small q. Similarly, volume of larger drop. So the volume of larger drop must be equal to n times n multiplied by volume of smaller sphere. Okay, smaller drop. Drop means sphere. So what is the volume of the larger sphere? So that is equal to 4 by 3 pi into capital R cube must be equal to n times the volume of a smaller sphere. So that is equal to 4 by 3 pi into small r cube. Okay. So 4 by 3 pi can be cancelled on both sides. So capital R cube must be equal to n times what? Small r cube. Therefore, what must be the relationship between small r and capital R? Taking cube root, right side will become n raised to the power 1 by 3 into small r. So this is our second step of understanding. So capital R is equal to cube root of n multiplied by the small r. Okay, now what is the potential on the surface of the smaller drop? That is capital V. So we get an expression for the potential V is equal to 1 by 4 pi epsilon naught into Q by R into Q by R. Is it not? Similarly, what is the potential on the surface of the larger drop V dash? So V dash must be equal to 1 by 4 pi epsilon naught into capital Q divided by capital R. Okay. So look at this V dash. 1 by 4 pi epsilon naught into capital Q. What is capital Q in equation 1? We are going to substitute there. And capital R in terms of small r we are going to substitute here. Okay. So V dash is now equal to 1 by 4 pi epsilon naught multiplied by n times small q. In place of capital Q, n small q I have substituted. In place of r, this is what? N power 1 by 3 into small r. Have you understood this step? I have substituted for capital R. Okay children, now you see here n power 1 in the numerator, n power 1 by 3 is in the denominator. So this is equal to n power 1 minus 1 by 3 into 1 by 4 pi epsilon naught into Q by R. Okay. But 1 by 4 pi epsilon naught into small q by small r must be equal to what? V. So this is equal to n power 1 minus 1 by 3 into V. 1 minus 1 by 3 is equal to what? 3 minus 1 by 3, that is equal to 2 by 3. Okay. So this is equal to n raised to the power 2 by 3 into V. Okay. Therefore V dash is equal to n power 2 by 3 into V. So which is the right answer? You see here the fourth option, is it not? Therefore, option D is the correct answer. So step by step, if you proceed, means you can get the answer. The reverse of this problem they are asking in the competitive exam. What is the reverse of this? A larger droplet is broken into n number of small droplets. Then find the potential V. Like that also they may ask. I hope you must have understood this well. Fine.